Go.
Hello there world, I'm Connor, this is Zach, and welcome to the fun world of chemistry. We are going to be going over some interesting things today, specifically chemical reactions, a way that particles and atoms try to get to the most stable possible state. We have a very interesting reaction for you today known as elephant toothpaste. Zach?
This reaction works as a decomposition of hydrogen peroxide with a catalyst of potassium iodide in this bottle here. We have a premixed solution already that is a saturated solution of potassium iodide of 70 grams potassium iodide to 50 milliliters of water. This will just accelerate the process. It does not get used up in the reaction. The reaction that takes place is just decomposition of this simple liquid here, H2O2, which produces hydrogen gas and oxygen gas. To see the effects, we have a sample of soap that will be mixed in with the reaction. The soap will bubble with gases that are produced instead of just vapor going into the air.
Creates a very interesting foam. Should we begin?
Yep. So first we add the hydrogen peroxide. Next we add a small amount of the soap.
I'll give this a little mix here.
Give it a little whirl. We have two samples of food coloring here, one red and one green. This does nothing for the reaction, it just makes it look cooler. So we're going to do it down the side, and this will have a striping effect on the final foam product. And now the catalyst will be added last. This will actually activate the reaction that happens. It just makes it look cooler. So we're going to do it down the side, and this will have a striping effect on the final foam product. And now the catalyst will be added last. This will actually activate the reaction that happens. We're going to want to move all of your chemicals to the side so that they don't get splashed by the resulting foam. Chemical mixing, when you're not in control of it, is always a bad idea.
It should be noted, this is an exothermic reaction that produces quite a bit of heat.
Give this a whirl here. Add it to the container and stand back. This is the elephant toothpaste reaction.
Thank you. Hello, welcome back to Fun with Chemistry. Now what we are working on is a very simple reaction, a common reaction known to probably just about everyone. It's vinegar and baking soda. What we're going to be doing here is mixing the two and using the carbon dioxide produced to put out candles.
This is the same basic reaction that you've seen at science fairs everywhere with the erupting volcano. What we're simply doing though is we're not pressurizing the gas that's escaped. We're letting the carbon dioxide sink back into this cylinder here. Because carbon dioxide is heavier than air, it will take the form of this glass beaker without escaping into the atmosphere. It's basically 1 gram of sodium bicarbonate, which is your basic baking soda, to 0.72 grams of vinegar. Basic white vinegar used to clean your house. Different bakery goods require it, you know. Vinegar used to clean your house. Different bakery goods require it, you know. So we mix the sodium bicarbonate, and then we add our vinegar. Bubbles slightly, no explosive reaction. To illustrate that there is carbon dioxide in this cylinder, I'll take the candle that can be moved around a bit more readily. Just into the cylinder, goes right out. Carbon dioxide. Without oxygen, fire cannot continue. So if you take full of clear gas, pour it right over the candle, goes right out.
Hello, and welcome back to Fun with Chemistry. I greatly regret to inform you that Zach perished earlier today in a tragic accident where elephant toothpaste caught on fire, destroying our entire lab and, unfortunately, him as well. In the meantime, I soldier on, demonstrating our final part of this 3-part series. The final reaction we are going to be going over today involves oxidation. Now, oxidization, as you may know, is where oxygen bonds with various other materials. In this case, we're going to be analyzing copper, which I have in these pliers here. Common forms of oxidization often include things such as rust, which you can see wrapped around this piece of wood on these chunks of iron. Now, the way that we are going to demonstrate oxidization is by creating a copper oxide on this little piece of copper. In order to do this, we are going to fire up a plasma circuit, 25,000 volts, 20,000 hertz, which will provide the needed energy to cause the reaction. Now, the circuit is live, and you should be able to see the arcs. It can form up to 1-inch streamers at times, and with proper exposure, it will eventually create a coating of copper oxide around it. It's believed that it's 2 copper to 1 oxygen. The resulting product will eventually look like this here, which you can see the red coating on what is otherwise normal copper. Thanks.